In my video about hadrons, I talked about how they decay. Why do particles decay, though? In the universe, everything tries to reach the lowest energy state possible. From planets pulling themselves into spheres to heavy atoms emitting radiation, everything tries to reach a lower energy state. In the case of fundamental particles, if there is an arrangement of particles with less mass, so less energy, that doesn't violate any laws of conservation, the particle or particles will spontaneously change into that arrangement. The laws of conservation that prevent all matter from decaying into pure energy are the law of conservation of energy, the law of conservation of charge, the law of conservation of lepton number, and the law of conservation of baryon number. What are these laws, and what do they do? The law of conservation of energy prevents energy from being created or destroyed. Based on this, shouldn't it be impossible for particles to change into particles with less mass, therefore less energy? No, it doesn't. The energy in the mass simply changes into another form of energy. This is why some decays yield fast-moving particles, motion energy, and others yield hot particles, thermal energy. The law of conservation of charge prevents any decay from having a change in the net charge of the particles. For example, if a down quark decays into an up quark, the net charge increases by 1. For this decay to occur, something like an electron would have to balance out the charge. This violates another law, though, the law of conservation of lepton number. Lepton number is basically the amount of leptons in existence in the decay. All leptons have a lepton number of 1, while antileptons have a lepton number of -1. Everything else has a lepton number of 0. To fix the decay, an antineutrino would be necessary because it wouldn't change the charge, but it would balance out the lepton number. Finally is the law of conservation of baryon number. Baryon number is basically lepton number for quarks. Every quark has a baryon number of 1/3 because a quark is 1/3 of a baryon. Every antiquark has a baryon number of -1/3, and everything else has a baryon number of 0. This is why single quarks don't decay into leptons or bosons. Because of the laws of conservation and the tendency toward lower energy states, all quarks other than down quarks quickly become up quarks, and taus and muons quickly become electrons. That is why pretty much all matter is made up of protons, neutrons, and electrons. Overall, everything tries to reach its lowest energy state, but there are some rules for how that can occur.